Okay, hi guys. Those who are here, right? If you all don't have the materials, they all let me know. I can reshare it again. By the way, just before I formally start, this session is supposed to be conducted by Teacher Clarence. Due to some emergency, I'm taking over him lah. So in case you are shocked why I'm here lah, okay? You all can hear me I'm very scared. Can you hear me no? Okay, very nice. Got a response. Sorry, just now I never see. Oh, 10 questions. Yeah, Teacher Clarence is a monster Okay, it's 7. I will begin the session first. Once again, if anybody didn't receive the materials or what, do let me know. I will resend it to you guys. Okay? So welcome everybody. Let me just double check this is recorded. If not, I will kill myself. Okay, yes, very good. Okay, welcome to Overmark WA2 session. Oh, okay, online revision session for Sec 1 to Sec 4. Okay, this is Sec 4 A Math for specific school clusters, Xingming Sec and TKGS. Okay, so hi everybody, this is Teacher Qian Wei over here. Once again, to share with everyone, I'm covering him because he has some emergency lah. Okay, so I will be taking over his session today. Uh, Meanwhile, the questions are not prepared by me. I am just taking over, so I seek your understanding if there is any issues lah. Yes, did someone? Oh yes, can we send the materials? No problem, no problem. Okay, can. Uh, so this is me, Teacher Xian Wei. Okay, I teach lower sec. I teach E-Math and A-Math. Basically, if you those who are at Tampines, you will know I teach everything there lah. Okay, Sec 1, Sec 2, Sec 3, Sec 4, A-Math, E-Math. Okay, upcoming also I'm teaching JC1 at Tampines as well. Okay, so these are my classes. Uh, so just share a bit of credentials. I recently graduated from NTU. Okay, bachelor's in mathematical sciences. Okay, did well lah. I'm a nerd lah, okay? And I have an exposure in H3 mathematics for those who's interested in like JC courses and stuff like that lah. So I took H3 mathematics. Yeah. I failed lah, but at least it's an experience, right? And some fun fact, I shared one fun fact last Sunday for those who came from my Sec 4 E-Math. I'm going to share a different one lah. If not, I'm going to say the same thing again, right? So I went to Vietnam last month and I'm going again in June. And I went again 2 years ago. I went 2 years ago. Lol. Yeah, and it's all at Ho Chi Minh. No why also. Okay, so just to share with everybody, Overmark has existed for quite a while already. We have around 1,000 students around every year. Okay, and under me, I have quite a number of students who I'm taking care of lah. My kiddos lah. Okay, and we have seven different branches across. For me personally, I teach at Tampines at Kovan on Sundays. For those who, if anyone stand teacher Clarence, he teach at Kovan and at Novena lah. Okay, so these two locations. But he teach mainly more at Kovan. For me, mainly more at Tampines. Okay, so I think this statistic over here, one thing is that as a whole, we do push for students to do well. I believe at least 70% managed to get their distinctions. For my own students, a lot of my students, personally, when I see my own students, they improve a lot lah for my O-level students last year. Last year, I didn't have a lot of graduating students, maybe only 9 only. Okay. All my students did a lot better than they thought they would. All of them. So I'm very happy for them. So that's that. And I will share this part later on, but because our materials today is actually quite long, there's 10 questions, so I hope to cover as much as I can. Rest assured, if I cannot really finish, the solutions will be uploaded. Okay, the materials and solutions are prepared by Teacher Clarence, but I will be using my own annotation to help you guys lah. So without further ado, let me just, I realized I never signed in using my iPad account, so let me just quickly join first. Okay, and then we will begin shortly. Okay. In the meantime, just to brief everybody, we are doing differentiation. Okay, mainly differentiation, and I believe for TKGS, you guys are also doing integration questions. Okay, I have TKGS students as well, so I know. Yeah. So teacher Clarence has kindly provided the questions catered to the integration lah, those that has a mix of integration questions. Okay, so not to worry. I will minimally cover the first 7 questions. Okay. If I have time, I will cover more. If not, I will just overrun lah. No problem lah. Right? Because I don't think I want to rush through all the 10 questions as well. But at the same time, I hope to give you guys some quality lah. Okay. So over here, I will just quickly touch through on main things that we are covering today. Okay, we are mainly looking at all the applications of differentiation. Okay, we are not really looking at techniques anymore. Okay, because I think for the crowd over here, you guys are pretty much done with the techniques as well. Even for integration. Okay. For my own TKGS students and Singmi students, I also pretty much went through the basics of integration, and we are already doing area under graph already. Okay, so just to recap, there is tangent normal. Okay, standard stuff. Increasing, decreasing functions where your dy dx is either less than 0 or more than 0, or more than 0 or less than 0 lah. And if it's not, we are really looking at stationary points and to determine the nature of the stationary points, whether it's a minimum or maximum. And last but not least, we also have rate of change. Okay, so rate of change where you connect two different variables under time, okay, with respect to time. So first thing first, we quickly touch on normal, tangent normal. Okay, tangent normal, if you remember, right? In coordinate geometry, you all will have learned that the product of a tangent normal is always equals to -1. Okay, I won't spend so much time on this. You will see in the questions, but hopefully you have a sense of what to do when we actually go through. So there's 2 things you can do. You can either calculate the tangent by substituting into your derivative. Okay, or if you want to find the normal, you take the negative reciprocal. Okay, so these things I'm just covering through so that you at least have a sense of what to expect lah. Okay, and as usual, you can also find the tangent and normal lines. Now, this formula no need to memorize. You just need to remember 2 things. First, you need to know the gradient, whether it is tangent or normal. Okay, then the second thing you need to know is your coordinates. This is typically in the form of x equals to a and y equals to fa. So when you substitute a particular value of a, you will have a corresponding of y. So you will end up using your formula y minus y1 equals to the gradient times x minus x1. Okay, so visually, the tangent is supposed to be a line that touches the curve at one point, and the normal is the perpendicular to the tangent. Okay, so far so good. Okay, can. Next, increasing, decreasing. This is very straightforward. If you are going up, your gradient is positive, right? You cannot be going up and then your gradient is negative, right? No such thing. Okay, so when f prime x is more than 0, then you will say that the function is increasing. Likewise, if it's less than 0, it is decreasing. So some examples over here. This portion, because you are going up, the gradient is actually more than 0. But as you cover the other portion, your gradient is negative. Okay, similarly, this part throughout you are just going up, maybe except for here, but actually this doesn't look like a 0 lah. It's still a positive gradient, right? So throughout this whole thing, this is increasing. Okay, let me write down increasing throughout on all x. Okay, so far so good. Next, by the way, just to check in again, for those who missed out, don't have the materials, I'm resending this again. Okay, next, stationary points. Same thing, I won't touch on too much. Okay, you just need to know that apart from more than 0 and less than 0, stationary points, you will always by default write dy dx equal to 0. But there is a catch to this. For stationary points, you can either have a minimum or a maximum, which you have learned before in quadratic equations. This is your minimum point and your maximum point. But we'll be able to extend this to any general graphs by simply considering 2 methods. First derivative test. Okay, first derivative test in simple language is you study the gradient at the point which is 0, and you will study the point before and after. We will study all these points and the gradients and then present them in a table like this. So if let's say the gradient is positive, it goes up. Then at the point of intersection, or rather the point of the stationary point, right? This is flat. And after that, you find that it is going down, then this indicates that it is a maximum point. Okay, I hope this is clear to you guys. Next, okay, minimum point straightforward. If it's going down flat, then up is a minimum point. The last scenario over here is this thing called a point of inflection, whereby you have this type of shape or this type of shape, where the stationary point exists, but it doesn't really sit under a maximum or minimum. Okay, for such situation, we will just simply conclude there is a point of inflection. It can either look like this or look like that. So very simple example, x cubed. This has a stationary point at x equal to 0, is a point of inflection. Okay? Second derivative test is an alternate to the first derivative test. Usually, okay, I won't go into details, but there is a difference in which one you should use. Okay? Straightforward, you just need to go and differentiate one more time. Okay? If you differentiate one more time, you will obtain the second derivative. Then the only thing that's left to do is to check if the derivative is more than 0, that point is a minimum point. If it's less than 0, it's a maximum point. How to remember? You just compare this to a quadratic equation. If you have, let's say, 2x squared, right? This is a happy face, this is a minimum point. So the leading coefficient is positive, d2y dx squared is also positive. Likewise, if you are looking at negative 2x squared, this is a maximum point. Maximum point, right? Because of the negative, right? Negative, high cortisol, high stress. So maximum point. Same thing, your second derivative will be less than 0. However, there is a scenario whereby your second derivative will be 0. In this case, right, I'm not going to prove this to you, but it turns out that this test is inconclusive. Okay, so this is possible. There are very rare questions whereby you will end up with this issue and then you have to fall back to the first derivative. So just take note of that. Okay, so the general rule of thumb is to use the second derivative if it's easy to differentiate again. If not, if let's say you do quotient rule, you do until you vomit blood already, right? Then you use the first derivative test. It's actually a lot easier. Okay, can? Or pause for any questions? Okay. If not, let's move on. Rate of change. This one, right? Rate of change is really just talking about your dy dx, dy dt, and your ds dt. Basically, anything to relate to change up the time. Okay, but the main focus over here is the dy dx. Okay, the main thing is that you need to identify the two different variables, your y and your x. Okay, and then link them to your time. So that's why you have dy dt and ds dt. So usually in questions, I will always ask students to take note, what are the two connections? Then these two will be connected by a function of y, a y function in terms of x, and then you need to differentiate this to get your dy dx. Okay, and how to obtain the connected rate of change? Simply just put this formula. Okay, usually, I mean, you will be asked to memorize this now. Okay, but how I like to remember is I always write dy dx equals to dy dx. Lame, right? But if you notice and if you treat this like a fraction, you can simply just divide dt and dt at the bottom. That's about it. Top and bottom. So this becomes one part, this becomes another part. Okay. I will perhaps try to show this later on, but if you attempt to cross multiply this whole thing, you will end up with dy dt equals to dy dx dx dt. So this is the connected rate of change derived from this definition. Okay. Now, the detailed questions, I will leave it to later. Now, before I go on, is there any other questions? Okay, if don't have, then I will proceed to question 1. Okay. If you all need me to slow down, please let me know. Okay, I know you're not very vocal. The email also not very vocal. I don't know why also. Suddenly not vocal anymore. Okay. Oh, this is the tutor's copy. Oops. Okay, come. Questions relevant to everybody. So this is just differentiation. Okay, I mean, I don't know whether there's any other students but feel free to sit in and learn Okay. Now, first thing first, the equation of a curve is given this where x is more than k. Now, usually when you see these type of questions, right, it's indicating to you a condition. And the typical condition is for which x is defined for some values. Okay, so 3 things to look out for. Either you look out for denominator equal to 0, logarithm inside the thing, or your tangent asymptotes. Only these three will have this kind of restrictions, right? Polynomials, all those don't have. Okay. So if you look very closely, this is a algebraic fraction, like a partial fraction lah. And you will notice that the bottom, there is a specific condition that we must fulfill so that this function is defined. We cannot let the bottom be 0. So assuming that we solve this equal to 0, right? You will find that x is equals to -1 is undefined. So therefore, this condition, okay, first thing first, x cannot be equal to -1. But if you notice very closely as well, this is a square root function. Square root function means this value cannot be negative as well. So what I'm going to do is I'm going to change this to a more than symbol. Okay, which means the value of k is actually equals to -1. I hope this is straightforward. Okay, this question is a very common one. I hope you guys know that. Okay, easy, then we move on to question part B. Okay, obviously the next part we are asked to differentiate. So differentiation, you look at the function first. Y is equals to 4x plus 2 over square root x plus 1. Okay, when you see this, you need to think this is confirmed quotient rule. Okay, how I will do this question is first thing first, usually what I tell my students to do is you convert the denominator into power half first. Okay, power half first. So x plus 1 inside. Then you can proceed to use your quotient rule. Now, the reason why we need to convert into power half is so that this portion over here, we can apply the power rule at the bottom. So therefore, differentiating this with respect to x, right? Okay, first thing first, always remember, differentiate top, copy bottom, minus copy top, differentiate bottom. Then denominator squared. Okay, maybe like write denominator squared. Okay, so differentiate top, copy bottom, minus copy bottom, copy top, differentiate bottom. Okay, I think by now you guys should be familiar with this lah. Okay, so first thing first, I differentiate top, it will be 4, then I copy bottom. Okay. Thereafter, I will minus differentiate bottom. Okay. Now, remember, there is a component inside here. Please ensure that you check for your chain rule. Okay, if there's any layers like kueh lapis like that, make sure you ensure you eat every piece of the kueh lapis, every piece of the banana. If not, you're wasting food, right? So you differentiate outside, you also must differentiate inside. Okay, then the next thing is to copy the top. Okay, once you have done that, you divide by the denominator squared. Since the bottom is power of half, if you square this power of half, right, you will end up with power 1. Okay, so the rest of this is you just need to go and factorize out this entire thing. Okay, most schools will teach you how to factorize out this thing called negative half. So I will do exactly that. But for me personally, I like to do this extra step. So what I will do is I will copy this. Okay, and I will multiply in, I don't need this anymore. I will multiply in x to the power of x plus 1 to the power of half, top and bottom. What I'm doing over here is to eliminate, to distribute this into the powers easily. So this goes into here, it becomes power 1. Okay, so I will have 4x plus 1 over here. On the right, half times this will give me 2x plus 1. So I settle this part first. Then I distribute this into here. The power half minus power half will become power 0, which means this term is gone, eliminated. Okay, and then finally at the bottom, this is power half, this is power 1. Total, the strength is 3.5. Half plus 1 is 3.5. So this becomes x plus 1 to the power of 3 over 2. Okay, the last thing to do is to simplify this step. Sorry, let me zoom out a bit. Simplify this step. Okay, expand out and simplify. You will have 2x plus 3. Okay, over this part over here, this 2 is the square root. Okay? Simple analogy, you just treat this as a square. The roots are at the bottom, so that's why the 2 is a square root. So I will put a square root, and then the power will be 3. So therefore, x plus 1 power 3. Okay, so that is your answer. This differentiation step like very tedious, but it is really like that. Okay? Okay, I'll leave this for a while. If anyone got anything else, you'll let me know. Okay. If not, next question is to explain why the curve is an increasing function. You are required to show that dy dx is more than 0. The word increasing means the gradient is more than 0. But you do not assume it's more than 0. It's your job to go and prove it. Okay? So let's have a look. Why is this more than 0? Okay, we need to first look at the gradient function first. Okay, so let's write dy dx equals to 2x plus 3 over square root x plus 1 cube. Okay, now if you notice, right, the denominator has a square root. And for the given x that we define, right, we need x to be positive, or rather, we need x to be more than -1, right? So since x is more than -1, we will notice that the denominator x plus 1 power 3, this is actually more than 0 because all square roots are more than 0. Yes, and it 2x minus 3. Let me check. No, it's 4x plus 4 minus 2x minus 1. So it's 4 minus 1 is 3. It's okay, no worries. Don't worry about it. Yeah. Okay, so this one, the denominator is more than 0. You also must show that for x is more than -1, you must show that the numerator is also positive. How to do it? Very easy one. Okay, so usually what I like to tell students to do is to take the definition first. Okay, I need to spawn a 2 over here. I see an x over here. I must spawn the 2. So I will multiply both sides by 2 so that I actually have the 2x. Then I need to spawn the plus 3, right? So in the next step, I will also say, oops, 2x plus 3 is more than 3 minus 2. So what I just did is I inserted the 3 on both sides. This allows me to conclude that 2x plus 3 is more than 1. But remember, what are we proving? We are proving that dy dx is more than 0, right? Is this positive? Yes. Because it is more than 1, it is confirmed plus chop positive. So, numerator. So, since numerator and denominator is positive, therefore, dy dx is more than 0. This proves that it is an increasing function. Okay? So any questions, let me know. I still have 9 more questions to go. Okay? I'll leave this for me first. Anything else, let me know. Okay, can let's move on first. Okay, next question. Okay, this is what we call, okay, the moment you see diagram, usually it's optimization already. It's stationary points already. Okay, so I just thought I'll share this with you guys, but not all the time. Sometimes a diagram can indicate a rate of change fraction, but usually it's stationary point. Okay, so this is a bubble cup tea with a capacity of 360 pi cm cube. Now, a tip for you guys, if you look at, if the question involves shapes, right, or solid, in this case solids, you are really looking out for 2 things: volume and surface area. Okay, so what you need to do is identify this thing over here. Is it volume or surface area? Actually, very easy one. You see the power, you know, is power 3, right? This is volume. Okay, if this is volume, then you are really just forming the equation based on the volume, right? So first thing first, I will write 360 pi equals to volume of hemisphere is 2/3 pi r cube plus the volume of the cylinder is pi r squared h. Okay, now this is a starting equation. We have formed a relationship, but our objective is to prove that the surface area can be expressed in this form. If you notice very carefully, I have two variables r and h, and you need to ask yourself which variable disappears. Okay, so think from the perspective of simultaneous equation, because you know that we're going to take in one equation, sub into another equation. Okay, so our goal is actually to sub in the h because h disappears, right? Normally you do simultaneous, you need to sub in the variable that you do want, right? So in this case, I will attempt to first divide all the pi first. Then next step is I will make this the subject. So r squared h is equal to 360 minus 2 over 3 r squared. Okay, once that is done, you simply just divide r squared on both sides. So it's 360 over r squared minus 2 over 3r. Okay, so now you have an expression in terms of h. Now, we are going to find the surface area, which is comprised of the top. This is 2 pi r squared. Okay, hemisphere surface area, the top surface area, the curved surface area is 2 pi r squared. The curved surface area of a cylinder is the circumference times the height. You imagine it's a piece of paper rolled up like that. This is 2 pi r, this is h. So therefore, area of cylinder, the curved surface area is 2 pi r h. And for the bottom is pi r squared, circle. Okay, so S is equals to 3, okay, let's write it properly. 2 pi r squared plus pi r squared plus 2 pi r h. Okay, these two obviously can combine. It will become 3 pi r squared. This over here is where we replace in the h. So 2 pi r replace this thing, copy paste, put here. Then expand and simplify. Okay, let me zoom in a bit so you guys can copy as well. So now we simplify. 3 pi r squared plus, I'm not very good at reading at this. Okay, 720 pi over r minus 4 pi r squared over 3. Does this look correct? I think it's correct. Okay, next. These two can be combined together. Okay, so if you just consider, right, this is a block, this is a block. So what I am taking is 3 minus 4 over 3. I will simply just use a calculator, which I hope it works. Yes, I think it works. Okay, I will just take a calculator. Okay, and take 3 minus 4 over 3. Okay, so this will give me 5 over 3. So combining them together, I will have 5 over 3 pi r squared plus 720 pi over r. Okay, yes, looks like I'm in the right direction. Okay, now the next thing to do is I observe that I actually factorize out a pi. So that's exactly what I will do. Pi bracket 5 over 3 r squared plus 720 over r. I have proved. Okay, done deal. So actually it's very straightforward. It's just that it's a bit tedious. Okay, but then some of you guys will be asking me, Cher, I cannot do this question. How? So that is where you need to do the next part first, because you see the question very generous, they already give you the answer for S. You know that you're going to differentiate this. You might as well just start from the next part first. Okay, so last year one of my students, I was doing a time practice with him, then he just spent 20 minutes on that one question, that one part. Then I'm like, bro, why do you spend so much time on that one part? Cannot do lah. Okay lah, eventually he got A2 lah. Very proud of him. Okay, so you start off with this. Okay, R can vary, so this is a variable. Now, ask you to find the stationary value of S, which means you immediately must dy dx, you must differentiate. Okay, in this case, it's ds dr. They also ask you to determine the nature. So two things to take note of. This question, you must pay attention to what they're asking you. If they ask you to find the stationary value of S, you must find S. Determine nature means you must either use the first test or the second test. So first thing first, I will just differentiate. ds dr is equals to the pi. I focus on differentiating inside. So this part using power rule, I will have 10 over 3r. This part will become minus 720 over r squared. Okay, I quick math this one already. Because when you're experienced enough, you know that 720 r minus 1, right? You bring down the power, this becomes minus 2. So it's minus and r squared. Okay, so this one, if you've experienced, you will get it very fast one. Okay. Now, if you are finding a stationary value of S, of course, you must let ds dr equal to 0. So basically what this means is that the inside portion is equal to 0. You actually don't have to care about this pi anymore. So straight away I will write 10 over 3r minus 720r squared equals to 0. Now, this is just a solving a fraction. Okay, which is something you have done in Sec 2. So this is this is not a Sec 4 kind of thing that you have done. It's more of a Sec 2 kind of thing that you are doing. So normally what people do, if you see two terms and you see a 0, you move one term to the right. So I will put 10 over 3r equals to 720 over r squared. And then from there, this one actually very straightforward. This r can move out to the top because it belongs to the numerator. Then you can simply just cross multiply. So if you cross multiply, you will have 10r cubed equals to 2160. Yes, 2160. And then from there, cancel the 0. R cubed equals to 216 and r equals to 6. Take note, there is no plus minus. This is cube root, not cube, not square root. Okay, no plus minus. Okay. So this is the value of r. Now we will go back to finding the value of s. So value of s, we know that r equals to 6. Therefore, s is equals to sub in your 6 into this r and this r. So I will just write down straight away. It will be, let's see, 5 over 3 pi, or rather, pi bracket 5 over 3 6 squared plus 720 over 6 pi. Pi is outside, sorry. Then this will simplify to 180 pi. If you are wondering how to simplify this, just key in this part in the calculator. So 5 over 3 times 6 squared plus 720 over 6, you will get 180. Then the pi outside, just copy. Done. So that is your S. Next thing to do is your second derivative. Okay, so this is where I will tell you, right? Will you want to differentiate again or would you want to do first derivative? So there are some preferences over here. Some students will prefer to use first derivative because, as I already said before, this is an idiot-proof method. Okay, you won't encounter inconclusive, so I must fall back. So some of my students are like that also. They like to play safe. But for this question, I think no need to play safe lah. Just do it lah. Okay, what's the worst that can happen? Do again, right? Okay, so I will differentiate again. Second derivative, d2s dr squared is equals to 10 over 3 pi plus 1440 pi r minus 3. When you sub in r equal to 6, you notice this part is positive, this part is positive, this part is positive. Everything is positive. So what can I say? d2s dr squared is more than 0. Remember I told you, right? If it's more than 0, you think of your quadratic equation. Yes, I got a question over here. What app is a calculator? Casio. Class B, but need to pay money one. So sorry. I'm paying money for using this every year. Yeah. Okay, so sorry to spoil your bubble, but if you want to use it, you can ask your parents lah. Okay, so since this is a minimum point, you will have that S is a minimum. Okay? Yeah, okay. Maybe I'll just show you. This is class V's. I don't know how to show you. Class V's calc. Yeah. You can reach out to me if you want to find out more lah. But I think it's okay lah. you probably don't want to buy this. $20 is not worth it. You can buy 4 Saizeriya meals. Okay, if you're done already, I'll move on in maybe 30 seconds. Haha, no problem, no problem. Okay, next question. Okay, let me know if you need to reverse. Okay, I need to move on a bit faster. 8 more questions to go. Haha. Okay, particle moves along a curve such that in such a way that the y coordinate is decreasing. Okay, this already hints to you this topic is a rate of change. Okay, if it's a rate of change question, you need to think of what to connect already. Okay, by the way, not all the time you must do that. There are some questions where you don't have to do connected rate of change. I don't know whether this one have. I never really looked through, but if have, we'll find out lah. Okay, so okay. By the way, I think there are some new people. Let me just share the copy again in case those who just joined don't have it. Okay, I recognize that place. That's wrong. Okay. Y coordinate of particle decreasing is 3 units per second. So you see the word decreasing and you see y is decreasing. This is dy dt equals to -3. I will straight away write this down first. Okay? Then they tell you that the x coordinate is increasing at 0.15 unit per second. So this hints to me that dx dt is equals to 0.125 positive. Now, this is where I will show you the magic. You see dy and you see dx. What do you connect? Obviously, dy dx. Okay. Some of you guys will ask me, Cher, is it dy dx or is it dx dy? You all don't know, right? Okay. Debunk the myth for you guys. Look at the function, look at the variables. This is y equals to 2 over square root 3x plus 1. Since y is a subject, you should have y at the top. This is wrong. So the connected rate of change is dy dt equals to dy dx dx dt. These two quantities I just sum in, I will find that dy dx is equal to -3 divided by 0.125. This will give you -24. Okay? By the way, if there's any mistake, let me know. Because I'm just looking through answer key. But I hope you guys understand what I'm trying to say. Okay, don't worry, I'm not just blindly reading out answer key. I am guiding you guys as well. Okay? So once you have this, you will have this. Okay? Next. We don't have an expression for dy dx. Okay? So now what we need to do is to take this function and to differentiate it. Okay? If you study this very closely, right, some students will think this one looks like a quotient rule kind of thing, right? But if you notice very clearly at the bottom, this is actually more like a chain rule. Okay? What do I mean by that? You just bring up. You see, this one, if you just bring up, it will just be 2 bracket 3x plus 1 to the power of -12. This can be done without quotient rule. It is just chain rule. Okay, so that is what we'll be doing. We will first write dy dx is equals to differentiating 2. Okay, by the way, let me rewrite this part. Okay, the 2 is a constant. We can just put it outside. And then we proceed to differentiate 3x plus 1 to the power of -12. From there, chain rule tells me that I first differentiate the outermost layer. So if you think of this as a banana, the outermost layer is the power. I will bring down the power. So 2 times -12. Then when you peel the banana, you have not eaten the banana, right? So you still have the banana intact. The inside is intact. Okay, so this part protected, nothing happened. Then the power will become -3/2. Okay, and then we need to check for chain rule. There is a 3 over here, so I will multiply by 3. Okay, thereafter cancel, simplify. I will have -3 over square root 3x plus 1 power 3. Okay, so this is supposed to be equals to negative 24. Okay, what I have now is an equation. So with an equation, I can now proceed to solve for x. Okay, so I need to solve for x first. Solving for x, very simple. Copy paste this. And then you notice I can just cross multiply. Okay, let me just zoom out a little bit. Cross multiply. Okay. Before that, if you notice, negative 3 and negative 24, I can actually cancel first. So this is what I will do. I will cancel 8. Okay, then go ahead and cross multiply. So 1 is equals to 8 square root 3x plus 1 cube. Okay. Thereafter, I can, let me double check if I did this correctly. Okay, now I can divide the 8 on the other side. So square root of 3x plus 3 power 3 is equals to 1 over 8. Then I will square both sides to get 3x plus, oh, not 3x plus 3, 3x plus 1, sorry. Okay, 3x plus 1 power 3 equals to 1 over 64. Then I proceed to cube root. Basically, what I'm doing is, as I'm simplifying, I will take out whatever element is the outermost layer. So for example, square root is the outermost layer, I will square it to remove it. Then cube is the outermost layer, I will cube root to undo it. So I will have 3x plus 1 equals to 1 over 4. Then from there, solve for x. X is equals to negative 3 over 4. Sorry, 3x equals to negative 3 over 4. X equals to negative 1 over 4. So this is the value of x. Okay, hope it's not too rushed for you guys. But remember, the question is asking for the y coordinate. This is the x coordinate where this entire scenario happens. So what I need to do is to sub in this back into your y equation. So y is equals to 2 over square root 3 times negative 1 over 4 plus 1. Using a calculator, you will get this is equals to 4. Okay, so I will just prove it to you guys. Ooh, I don't want the whole thing. Yes, like that. Okay. Okay, you all can copy down while I verify to you guys that this is true. Okay, so 2 over square root 3 times negative 1 over 4. Please put bracket if you want it to. Okay, I just do it lah. Play safe. Okay, answer is 4 indeed. Okay. I hope this is clear to you guys. Okay, once I finish question 4, I'll give you guys a break. Okay, let's move on to question 4. Okay, question 4 won't be too difficult. It's pretty much the same lah. So same thing, function. Okay, a point moving along the curve. They ask you to find the coordinate of the point where the y coordinate decreases at the rate twice of the rate of x coordinate. Actually, this question very nice to work with one. You know why? Because all you have to do is to link the two of them together. This over here is dy dt. This over here is dx dt. And they said that dy dt is twice of dx dt. So what does that mean? This means that dy dt is equals to 2 times of dx dt. And if you remember very clearly, right, I did show you before that this is something like a fraction, but it is not lah. Okay, I will just be honest, it's not. But you can pretend that it's a fraction. So when you see this, obviously you're looking for dy dx. Okay, so there are two ways to approach it, but I will just stick to an easy one. Okay, this part over here, I will simply divide both sides by dx dt. So dy dt, okay, let's write it properly. Okay, where is my back? Yes. Okay, dy dt over dx dt is actually your dy dx, because if you notice, it's like cancelling this thing. Okay, so this is equals to 2. Oh, by the way, sorry, y coordinate is decreasing means I must put a minus sign. Okay, so please don't forget about that. Okay, so it is -2. Okay, I just thought I remind you guys on this. Okay, decreasing and increasing. Okay, so we have a value of dy dx. Okay, now I just want to also add on a lot of questions, right? They will phrase it in a way that you need to go and find the dy dx value first. Okay, so this is something that I would say is very dynamic. You guys need to look out for that. But the process is the same one. Once you have the value, you link it to the expression, solve it, like what we have been doing. Okay, so dy dx is -2. Obviously, we must differentiate this. Okay, so to differentiate, okay, first we need to differentiate. The 4 can put outside. We will focus on power -half. Okay, transforming into this, we will have 4 times of -half x plus 3 power -3/2. Okay, and then from there, this will become -2 x plus 3. Sorry, let's put it at the bottom. -2 over the square root of x plus 3 power 3. Sorry, square root x plus 3 power 3. And this is apparently equals to -2. Same concept. This is an equation. Okay, this is an equation. So I will just take this, cancel. I will be left with, after cross multiplying, 1 is equals to the square root of x plus 3 power 3. Squaring both sides, I will have 1 equals to x plus 3 power 3. You cube root, you also get x plus 3 equals to 1. So therefore, x is equals to -2. This is the value of x. But they want the coordinate. Okay, whenever you are almost done already, go and check what they want you to find. Coordinate means you must have the y value. So when x equals to 2, let me move this out of it. Okay, when x is equals to -2, you will find that y is equals to 4 over square root -2 plus 3 equals to 4. Therefore, the coordinate is -2 and 4. That's it. Okay, sorry, the order looks a bit funny, but it is, I minimize the disruption lah. Okay, so maybe to help you guys, this is step 1, this is step 2, and then this is step 3. Yep. Okay. So I promise you guys a break now. Okay, I'll give you guys a 5 minutes break because I think it's quite rushed. But I hope it's clear enough for you guys. So if any feedback, you can let me know as well. Yeah, so I will be setting a timer, 5 minutes. Okay, any questions, just let me know. Okay, you can go toilet break, everything, go and chill first. Okay, any questions, just let me know. Oh yes, I got a question. So if this other variable like letters, the method is the same. Yes, correct. This one, let me look through first. Okay, I don't think there's a lot of other variables here lah. But yes, you're right. If let's say they say V, okay, let's say for example volume is decreasing, right? Let's say you talk about a cone where you pour water inside. So normally what are the variables? Okay, I just draw it out for you. So it's a cone. You normally will have volume related to height. So height is like that. Okay, so in this case, it will be dV dH If you are doing connected rate of change, it will be dv dt dh dt, like that. So it's the same thing. Okay? Let me know if you need more clarifications. It's another question. Oh, I can. Okay, can. No problem. I'll send it to you again. Okay, no problem. Okay, let me erase this or put it somewhere else because it is not part of the question. Later confused. Okay, let me know. No problem, no problem. Okay, very happy to help. Yes, another question. How do you know which one to put in front? For example, dy dt, dy dx can be like dy dx is in front. I'm not sure if I understand this question. Let me look again. Which one to put in front? Okay. By default, if you look at dy dx, another way I like to remember, right, is that on top is the main subject. Like, when you differentiate, it is always like y equals to a function of x, right? So if this is a subject, then obviously this will be the subject as well, dy dt. Then on the right, it will be dx dt. So subject on the left, the subordinate is on the right. I hope that makes sense to you. Is y coordinate always dx dt? What do you mean by that? They said, okay, you need to read at the language. They said y coordinate is decreasing. So if it's specifically y coordinate, is dy dt. If it's like I said before, right? If it's like the water being poured in at a rate of this, then it is dv dt. Because the language over here is water poured in. Water is measured as a volume. So it's dv dt. So it depends on the question. If they say y coordinate, yes, it's dy dt lah. Okay, but you must make sure that it is a rate of change, not just a regular y coordinate. Okay, I hope I answered the question. Can? Let me know. So, okay, I think directly answer the question, the y coordinate increasing, decreasing is dy dt, correct? Yeah. Okay, let me copy this again. Still have another 35 seconds. Oh, will the recording be an annotated copy be sent to us? Yes, will be done so. This one, don't worry about it. Okay, I will cancel the timer before it sound off because the sound very irritating. Okay, I don't want to wake you up. So, gentle waking lah. Don't want to abruptly interrupt all of you. Okay, so let's move on to question 5. Okay. Okay, question 5 looks a little bit better. No, it's not. 6 marks. Oh my god. Okay, this is I mean, if you do a quick scan, this is normal, tangent normal question. Okay, so don't worry first. First thing we're gonna do is we're gonna identify all the crucial points first. Okay, for tangent normal, when you want to find the equation of a normal, it's the same thing as finding the equation of a line. So two things you need. One, gradient. Two, coordinates. Okay, so they say the normal where the curve passes through the y-axis. Now, this is the point where the normal is of interest. So y-axis means, let's say the curve is like that. Okay, so this part is your tangent. Whereas this part is your normal. Okay, so the main thing is we must first identify the coordinate first. So we will tackle number 2 first. This happens when x is equal to 0. That is your that is your y-axis. So when x is equal to 0, you find that y is equal to 0 plus 11 over 0 plus 3, which is 11 over 3. So the coordinate where this happens is 0, 11 over 3. Okay, so just take note of that. Next thing, we need to first find the derivative because gradient of a curve, okay, cannot be solved using coordinate geometry methods. You must use differentiation. Okay, when you want to find the gradient of a curve, you automatically use differentiation. Okay, only straight lines, then you can use your gradient formula, your y1 minus y2 formula. Here cannot. You see curve, straight away dy dx already. No need to think one. Okay, so dy dx, this one obviously is quotient rule, no other way out. So we will differentiate top, copy bottom, minus differentiate bottom, copy top, denominator squared. Okay, this one really must go and practice more for you to be familiar. Okay, I don't want to spend too much time on techniques. So now, simplifying everything, 5x squared plus 15 minus 10x squared minus 22x. Okay, simplifying further, let me zoom out a bit. Okay, minus 5x squared minus 22x plus 15 over x squared plus 3 squared. Okay, now obviously we want to find the gradient when x is 0, right? When x is 0, the tangent, the gradient of tangent is f prime 0. F prime 0 is 0, 0, 0, 15 over 3 squared, which will give me 15 over 9, 5 over 3. Okay, so the good thing about subbing in 0 is really you just mentally see gone, gone, like that, gone, like that squared. So it's 15 over 3 squared. Okay, then this is our tangent. Our normal gradient is by definition, negative reciprocal. So it is negative 3 over 5. Therefore, we use the formula y minus y1 equals to mx minus x1. So we know that x is 0, y is 11 over 3. By that, we will have y minus 11 over 3 equals to negative 3 over 5x. Since the point of x is 0, we just leave it as x. So moving around, 3 over 5x plus 11 over 3. Okay, some of you may ask me that, oh, sir, this one is your y-intercept, this is your gradient. Can I just put in directly? Yes, you can, no problem. Okay, so internalize this for a while first. Okay, this is an easy question, to be honest. Okay, next. Determine the range of x for which fx is decreasing. Okay, so this time around, they tell you that fx is decreasing. It is a fact. If it's a fact, you can just use it. Okay, so first thing first, we need to take this part and then we let it be less than 0. So f prime x less than 0. Straight away we write down negative 5x squared minus 22x plus 15 over x squared plus 3 power 2 less than 0. Now obviously, look at the bottom. Bottom is positive because it is a square number, right? So if x squared plus 3 squared is more than 0, we immediately know that the numerator must be negative because it is negative divided by positive gives me negative. Okay? So we will just copy this down first. Let it be less than 0. Yes, I got a question. How to get your C? What C? Y-intercept, is it? Is what you're asking the y-intercept? Yes. Okay. Actually, it is given here already. Whenever the curve passes through the y-axis, right, this is automatically the y-intercept. And we found that the y value is 11 over 3. So this is the y-intercept. You can just straight away sub in. Got it? Okay, no problem, no problem. Okay, so let's go back to this question. Okay, negative 5x squared minus 22x plus 15. This part is a quadratic inequality. So listen up. I know there are some variations of where school teach you certain things. My standard is actually very simple one. I don't like the in front to be negative. And as much as possible, I would like to ensure that there is no common factors. So if there is any number I can divide, such that the whole thing remains a nice whole number, I will divide. Okay, so the negative I will divide So I need to flip. 5x squared plus 22x minus 15 is more than 0. Okay, so that this part is always a happy face. Okay, I will upload teacher Clarence's solution as well lah. His method is different from mine. He choose to continue from here. I don't like to do that, so I will do it this way. Okay, I will upload my solution and his solution. Okay, two people solution work is helps, right? Okay, so give you different perspective. So this one, right, you can factorize. Now I don't know if there's any one of you who don't know how to factorize. I will just do a quick one. I mean the O level, y'all should be know how to do it, right? Okay. So how to factorize is I will go to my calculator. I will go to this. Okay, for your case, it's number 5. Your calculator is different from mine. So press number 5 to go here. Go here, key in 5, 22, and minus 15. You get your roots 3 over 5 and negative 5. Okay. So how to get your factorized form? You use factor theorem for your polynomials to rewrite this. So for example, I cross multiply and I move to the left. Same thing, I move to the left. These are your factors. So even if you don't remember how to do it, calculator method works. So this will be 5x minus 3, x plus 5 more than 0. Okay? So just something for you guys to consider. This can be done in EMAP as well, but I don't know whether you need to write the table, this table or not. Okay, so once you have this ready, right, draw your happy face. Okay, you don't need the y-axis technically. Just draw your happy face. Okay, go and indicate your roots. Okay, your roots actually is from here one. This one don't need to write the solution. It's just for your understanding only. So obviously my two solution is negative 5 and 3 over 5, right? Okay, so obviously for this to be more than 0, you want to shade this part and this part. So your x solution is on the left of this intersection and on the right of that intersection. Now, of course, since this is a strict inequality, we will put x is less than negative 5 or x is more than 3 over 5. Done. Okay? Wait. Yeah, this is correct, right? 5. This should be correct. Okay, I just want to double check with you guys. This is correct, right? Should be correct lah. Negative less than 0. Yeah, okay, my answer is correct. Okay. Okay, I will leave this for a while. Any questions? Let me know. Okay, we are halfway through. We have a few more questions to go. Yes. Why is x less than negative 5? What do you mean? Why x less than negative 5? Because we didn't divide by negative. No, I did. I divided by negative. Why is x less than negative 5? Oh, this one is because of this one. It has nothing to do with anything on top. Did I answer the question? I divided the negative over here so that this quadratic is a happy face. So I only need to draw this curve. What type of rule do you use for the differentiation? This one is quotient rule because it is obviously something over something, which I cannot simplify. No problem, Damia. Okay, so this is quotient rule. Okay, if you cannot simplify it into any other form, it's straight away quotient rule. No need to think one. Okay, can? Okay, I'll move on. Thank you. Any more questions, let me know. Okay, don't worry. Okay. Question 6, right? I will. What should I see first? Let me see. Okay. I will do question 6 later on because question 6 is quite repeated lah. It's a repeated question. So I will do question 7 first. Okay. If I got time, I'll come back and do question 6 to have recording lah. Later on. Okay, because I want to spend more time on the variety of questions. Okay, although question 6, the style is a bit different. So if you are able to stay on, I confirm will overrun 10 questions. Okay, so maybe you want to stay on. Okay, question 7. Okay, so for those who asked me earlier on, what is the type of question, what kind of rule it is, right? If you look at this cannot be simplified into anything else. It is going to be a quotient forever. So obviously, I'm going to use quotient rule. Okay? But before that, state the value of k. Familiar, right? This one is got to do with the definite with your x being defined for certain values, right? So obviously the bottom cannot be 0. You let this equal to 0. You solve x equal to 3. So therefore, value of k is 3. Okay? Next, find the equation of the normal to the curve at this point. Same thing, guys. What are the ingredients you need to have? Go and think about it first. Okay, what are the ingredients you need to find the equation of a normal? Okay, you should know your answer in your heart. This is gradient and coordinates. Okay, for gradient, you need to first find the normal first, the derivative first. For coordinate, this is quite easy. So we will first let x equals to 4. F4 is equals to 2 times 4 plus 1 over 4 minus 3, which is negative. Wait, 9. Okay, so this one is 9. Let me put it on top a little bit. Okay, once we have that already, right, we settle our number 2 already. Now our job is to find number 1. So let's differentiate this. Okay, differentiate top, copy bottom, minus differentiate bottom, copy top. Okay, the derivative of x minus 3 is just 1. I never bothered to write down. Okay, then over. So let me erase this first because I think you guys will be confused. Let's do this instead. Okay, so this is over the norm squared. Simplify the numerator, you will realize that it is minus 7 over x minus 3 squared. So this is your derivative. Okay, first thing first, we need to find the tangent before we find the normal. So tangent with sub x equals to 4, this will give me negative 7 over 4 minus 3 squared. This is going to give me negative 7. And so the normal gradient is the negative reciprocal. So therefore, the equation of the normal is y minus 9, which is from here. This is our y value. Okay, let's write down y equals to the gradient x minus the x coordinate of the point. X equals to 4. Okay, from there, we need to simplify everything. Y is equals to 1 over 7x minus 4 over 7 plus 9, which is 1 over 7x plus 59 over 7. Once again, to verify this, 9 minus 4 divided by 9 will give me divided wrong. Okay, will give me 59 over 7. So that is our equation of normal. Okay, let me use a different color pen to indicate. Okay. Why is it 1 over 7? Okay. Do you remember how we got the gradient? This is the tangent. Right? You remember, tangent and normal, they are related by this thing called a negative reciprocal. So the tangent times normal is equals to negative 1. This is from your Sec 3 coordinate geometry. So the normal is equals to negative 1 over tangent. That's why you flip the 7 into here and you multiply by a negative, become positive. Okay, is this clear? You might have forgotten about this already actually. Yeah. But do let me know if you understand. Okay, very good, very good. You forgot about it lah. Okay, again. Just do a quick revision on this because it's tested for coordinate geometry and for this topic as well. Okay. Yep. So next thing is to explain whether this function is increasing or decreasing for x is more than 3. Once again, you need to take note of the condition. Condition is x is more than 3. F prime x, because we are investigating the whether it's increasing or decreasing, we look at the gradient function, which is -7 over x minus 3. Now, since x is more than 3, we can write x minus 3 is more than 0. What does this tell me? This tells me that the bottom is positive. I square the positive, it doesn't matter what it is still positive. So therefore, since x minus 3 squared is more than 0, therefore, f prime x is equals to -7 over a positive number. Okay, as I remind you guys, negative divided by positive is equals to negative. So therefore, this is less than 0. So since the gradient function is less than 0, we can conclude, is this increasing or decreasing? This should be decreasing. Okay? Yeah. All right. Okay, part D. Wow, so many parts. Wow, left 20 minutes only. Okay, determine whether the gradient of the curve is increasing or decreasing for x is more than 3. Okay, so if x is more than 3, right? Wait. Oh, this one take note. This question very tricky. They said the gradient of the curve is increasing. What do they mean? They want to find out whether f prime x is increasing or decreasing. By this definition, this function is treated as another function gx. We want to investigate whether gx is increasing or decreasing. So our job is to prove whether gx is more than 0 or gx is less than 0, which means we must, whether g prime x is more than 0 or g prime x is less than 0. In other words, this is the equivalent of finding the second derivative. Okay, you need to pay attention to what they're looking for. If you are looking at the gradient of a curve is increasing or decreasing, you must differentiate the gradient again. Okay? So f prime x is the same, double prime x is the same as -7. Differentiate x minus 3 power -2. So how do I get this? I take this denominator and move it up in the power. Okay, then I proceed to differentiate using chain rule. So -7 -2 x minus 3 power -3. This will give me 14 over x minus 3 power 3. Okay, so the first thing you need to understand is that I must differentiate this again. Okay, once I differentiate again, then I can proceed to determine whether this part is increasing or not. As we already know earlier on, x minus 3 is more than 0. This means that x minus 3 cubed is also positive, which also means denominator is positive. So what does that mean? It means plus divided by plus, you will have what? F double prime x is equals to, it is more than 0. It is increasing. Okay? Very important to take note of that. Okay? Any questions? Also, I thought D and the C are the same thing, just typo. I just realized they are very different questions. Yeah, I believe this one got people got questions, but so just ask. No problem, just ask. Okay, no? No, then let's move on. Okay, next question. Question 8. Okay, I got 4 more questions. I hope to finish this soon. Okay, equation of curve is y equals to 2 power e power 2x over, okay, this one relevant to TKGS only. Actually, in that case, then I will just go through question 6 first lah. Okay, so that in case there are parts that is not relevant to the rest of the audience, I don't waste your time. Okay, so we do question 6 first. Okay, but of course, you're welcome to stay. Okay, so let's look at question 6 first. Okay, go to question 6. Okay, let me zoom this in a little bit so that you guys can see better. Now, a company manufactures open square base keyboards. Square base keyboards means the base is square base, no? But the height may not necessarily be the same as the base area of the square, right? So what is going to happen is that, okay, x is the length of the side of the base. Okay, the materials for the base of the casting cost twice as much as the materials for the sides. So base, this is base, this is side. You have 4 sides, 2 base, right? So total costing of one casing is $600. Okay, so this one casing, with the materials for the side costing $1 per cm cube. Okay, so what we need to do first is to look at the question. Okay, look at the information first. Okay, the height we don't know. So we will first let height be h. Okay, so if the height is h, we first need to look at all the sides first. Okay, we have the 4 sides. Okay, and there's really no other 4 lateral sides is going to be different from the top and the bottom. Okay, so therefore, we will first consider h times x. That will give you the square, this part. And there are 4 sides. Okay, so back, left, right, front. Okay, this will be 4xh. And the material for the bases is 2 times of x squared. Hold on. Is the top open or not? Oh, yes. The word says open square base. So there is only one. The top is open. Okay, so let me write down. The top is open. So anyways, one thing to warn you guys as well, when it comes to such questions, right, you need to be very careful. They will sometimes tell you that the top is open or this part is open. You need to pay attention to this as well. Okay, so there's any open spaces, you need to exclude them. Okay, so the cost for 4 sides, as they said, the materials for the base is twice as much. Okay, so the total cost is 4xh times 1 unit, because they said that the material of the side is $1, right? So this is $1 is given here. Then you add in the base, which is twice the amount, is $2. So this will give me 4xh plus 2x squared. Now, the total cost of one casing is 600, which means this is actually 600. So once again, you need to link the information to what's provided. If they give you the total cost of the casing, you can form an equation related to the total material cost already. So that's why it's motivated by this. Then if you look again, volume of casing is the one you are finding, right? We want to show that the volume is this. Now, once again, look at the variable. Which one is missing? Is the one that we will use that to sub in. So h is missing. If h is missing, I make h the subject. So taking this as the equation, 4xh is equals to 600 minus 2x squared. H is equals to 150 over x minus x over 2. Okay, so that is my height. So therefore, the volume, okay, volume V is equals to volume of a cylinder is, okay, take note, volume of the volume of a prism in general is base area times height. Base area x squared. Height is h. So I will write 150 over x minus x over 2. So this will give me 150x minus x cubed over 2. Combining them together, 300x minus x cubed over 2. Done. That's it. Okay? Okay, any questions? Let me know. Once again, if you don't know how to do this question, you can always do part B first. So V is equals to 300x minus x cubed over 2. We know we want to find the stationary value of V, so we must differentiate. So dv dx is equals to, first, the half we can take out. We focus on differentiating the numerator. So we focus on differentiating the numerator. 300 minus 3x squared. Okay? Now, next thing, we know we are finding stationary value. Obviously, we want to let the... Yes, I got a question. How is the volume linked to cost? Okay, I'll answer that later. Okay, first thing first, dv dx is equal to 0 because you are finding stationary value. So, you once again, let the inside part be 0. 300 minus 3x squared equals to 0. Okay, you are solving a normal equation. So 300 equals to 3x squared, x squared equals to 100, x equals to 10. Obviously, reject negative. So if x is 10, we go back to the volume. Volume is equals to 300 times 10 minus 10 cubed over 2. And that will give me 1000. Am I right? 3000 minus 1000 over 2. Yes, 1000 cm cubed. Okay, and then the next thing to do is to find the nature. Okay, so nature, same thing, second derivative. I think it's very obvious. We want to differentiate this again because it's easy to do so. So to differentiate again, just take reference from here. The half is outside. I will be left with minus 6x. So this is negative 3x. Obviously, x is positive, which means the second derivative, okay, if this is positive, the whole thing is negative, which I mean is really just equals to negative 30 lah, which is less than 0, right? So therefore, the cost is maximized. That is all. So find the volume, prove that it is a minimum or maximum. Okay, I got two questions. Okay, why is dv dx equal to 0? Because when you want to find a stationary value, right? Stationary means the gradient is flat, 0. Stationary means you are just standing there, not moving, right? So that's why you let dv dx equal to 0. Okay? For the other question, oh, wait. Wait, I got a lot of questions already. Let me double confirm whether you understand. Okay, can. Let me answer Emily first. Sorry to read out your name. Sorry. Okay. How is volume linked to cost? Because we first need to find the expression of cost first. You understand how we get this, right? Okay. The thing is that we found a relationship of the volume with the variables, but we want to find the volume, and the volume is actually your x squared, your base area times height, right? But this formula, you notice, does not have the h. That's why we need to use the cost, make h a subject to replace it so that there is no more h. That is how the volume is linked to the cost, and it is often like that. Okay, if you go back to the question 1 that we did earlier on, right? Not question 1, question 2, same thing, we find the volume first. Sorry, you use the volume to find the height first, and then to sub it into the surface area so that we eliminate one variable, the one that we don't want, which is the height. So same for question 6, we eliminate that variable. Okay, I hope this answers your question. Last question is, how do I know when to use first derivative test and to determine the nature? Okay, the rule of thumb is this question, if it's easy to use second derivative, you can just use it. By default, if you most certainly prefer to use first derivative, there is no harm, you can just use it. So it's not the only question is, if it's too difficult to use second derivative, you use the first derivative. So an example of this question is if you have a quotient rule. Quotient rule, you confirm die one. Yep. Okay. So I hope I answered the question. Yep. Very good. Okay. Wow, I only left 7 minutes only. Okay. I will quickly try to run through the remaining 3 questions. I hope I'll be fast, but confirm you guys okay? I hope you guys are okay. Now, if you all are overrunning in schedule, you all can go ahead and leave first. No problem. Okay. Let's look at question 8. Okay, so this question will probably involve a little bit of integration. So if this part is not relevant to you, okay, at least for question 8, though there's no integration lah. So you can go ahead and proceed. Is that integration? I also don't know. Okay. Let's have a look first. Find the exact coordinate of the stationary point of the curve, leaving your answer in exact value. Okay. So this question, stationary point, right? This is you need to differentiate already. Okay. How to differentiate? This is a quotient. I would most certainly just differentiate using quotient rule. So dy dx is equals to differentiate top. Yes, I got a question. Why is it relevant for TKGS? Okay, because there is element of integration, but from the answer key, I don't look like there's integration. So I think there's no harm to just stay lah. Also because these questions all got exponential, trigo, and logarithm. I think that's the reason why. Yeah. You guys are tested for this also, right? I remember both schools is tested for exponential logarithms. Yeah, but you can just sit through lah. I think it will benefit you. Oh, you're G2. Oh, okay. Then this is irrelevant to you already. Okay. Then I think you take a leave first. Because this is not relevant to G3, G2. Okay. Any G2s here, you all can go. But hope to see you guys around. Okay. Thank you. Okay. So now let's differentiate first. For the on top, okay, you use quotient rule. You differentiate this, you bring down the 2 and you copy this thing down. That is how you differentiate exponential functions, right? It's what I call the Godzilla. You kick the Godzilla, nothing will happen. But the child inside the 2x, okay, the child has to drop down, so they'll be left with 2. Recording will be on YouTube. Yeah. Okay, so we differentiate this first, copy bottom, minus differentiate bottom, copy top, over the norm squared. Thank you so much. Okay, so once you have this ready, right? Okay, go ahead and simplify this. Okay, stationary point, usually for stationary point, I won't. Okay, this is a tip that I want to share with you guys as well. If you don't need to use the expression of the gradient, you actually don't have to continue from here. But I look at part 2, I need to differentiate this again. I will think about it. But maybe okay, let's just simplify this. Because sometimes I will not simplify this if I'm only finding if I'm going to let it be 0 and solve the numerator. Yeah. So never mind, I will just expand this. 6e2x plus 8xe2x minus 4e2x over 3 plus 4x power 2. So this will give me 2e2x plus 8xe2x over 3 plus 4x power 2. Okay? So one thing to take note of is that you might want to factorize out the e2x, because sometimes if you're asked to prove increasing, decreasing, it is a good idea to just factorize it out, because exponential functions are always positive. So sometimes I'll just write it like that. It's a lot easier. It's a good habit actually. Okay, so once we have this ready, right? Stationary point, stationary point is when the dy dx is equal to 0. So same thing, numerator is 0. I won't even bother about the bottom. But as you already know, exponential cannot be equal to 0, right? So therefore, you only need to solve this part more than 0. So x is equal to negative 1/4. From there, find the value of y to get your coordinates. Okay? So y is equals to e2 times negative 1/4 over 3 plus 4 negative 1/4. So this will give me negative 1.5 over 2. So this therefore will become 1 over 2 square root e. So therefore the coordinate is negative 1/4, 1 over 2 root e. Okay, so that is the coordinate of the stationary point. Okay? Oh yes. Okay, can Okay, now next part. Determine the nature of the stationary point. Okay, same thing. Okay, this is where I'm going to tell you upfront. There are people who ask me, hey, Che, when should I use first derivative? First derivative test. You look at this expression, you ask yourself, you want to differentiate this again? Don't want, right? It's painful, right? So this is what I will do. I will draw a table. Okay. I will split this into so. Okay. Okay, I will draw a 3 by 4 grid. And on the left, I will put x, dy, dx, and sketch. Okay? So, here's the thing now. We are going to investigate the nature of the stationary point of the curve. So, if let's say you draw the curve, you want to find what is the nature of this stationary point. You obviously must look at the left and on the right. Same thing as when you cross the road, you must look left and look right. Look left, look right. Okay, so the stationary point happens at x equals to -1/4. Obviously, you will look for what is on the left and what's on the right. So a quick example, this point, for example, you can sub in -0.26. Here, you can sub in -0.24. So let's do a quick demo. Okay, the gradient, well, the gradient very painful to calculate. Whew. Okay, it is e to the power of 2 bracket 2 plus 8 bracket close bracket again 3 plus 4 bracket close bracket squared. Okay, so what you notice is that I actually key in everything, replace all the x with a bracket, which is what I'm doing over here. So of course, let's say for example, I want to key in the number on the left of -1/4, which is -0.25. So let's say I put -0.26, right? So -0.26, -0.26. At the bottom, -0.26. So it turns out that this is actually a negative gradient. So negative, let's write down this negative. Here is 0. Then this will be going down flat. Now we just need to verify that this is increasing or decreasing, right? So same thing. I will change all these numbers inside the bracket to 4. 0.24. -0.24 to be specific. So I just change. You notice I maintain the integrity of the function. All I do is just to change the numbers. Then you see the number come out very fast already. So this is a positive gradient. So therefore, going up, we can conclude this is a minimum. Okay, so -1/4, 1/2√e is a minimum. So this is a simple trick with the calculator. I hope this helps. Okay. Wow, looks like I'm very fast today. I left 2 questions only. Okay. So, any questions, let me know. Okay. Can Okay, if not, next question. Okay, question 9. Okay, I'm going to go. Wow, this is a bit long. 9 marks. But actually, usually 9 mark questions quite simple. If I were to do it, I think it's quite simple. Okay, so question 9, right? The point P lies on the curve over here. Okay. Normal to the curve is parallel to this line. Equation of the tangent cuts the P at the y-axis. Okay, whoa. A lot of information over here. But you know one thing for sure. You must differentiate. But before we carry on, you look at this function. You are going to differentiate this directly? No, right? So you should try to simplify this. Okay, for logarithms, right, you should split them up. Ln x plus 1 minus ln x minus 1. Okay, so you are differentiating y equals to ln x plus 1 minus ln x minus 1. So when you differentiate, you will get 1 over x plus 1 minus 1 over x minus 1. Okay, now we are ready to proceed with the next part of the information. So the normal to the curve is parallel to this. First thing first, we will, you see, the keyword here is parallel to this line. But we cannot infer the gradient directly unless we rearrange this. So 2y equals to 3x plus 2, y is equals to 3 over 2x plus 1. Which means this part, okay, we already have the y equal mx plus c form, right? This is the gradient. Okay, so this, the normal at P is 3 over 2. Okay, the gradient. Okay? Which means the tangent at P is negative 2 over 3. Once again, it is the negative reciprocal. Okay, so once you have this ready, right, the next thing to do is you should combine them together. Or rather, this thing is equals to negative 2 over 3. Okay? Hence, now our job is to solve for x. This becomes an equation, and in fact, this is an algebraic equation. Okay, so algebraic equation, normally what you need to do, combine the two fractions together first. Okay, this is a technique that you guys have been familiar in Sec 2. So, x minus 1 minus x plus 1 over make same denominator. Okay, so this is nothing more than just a Sec 2 technique. Okay, really just make the denominator the same. Okay, I write down make denom same. If you need to take extra effort to go and combine them together, go ahead. But I will just proceed with this. So this numerator will simplify to negative 2 over the bottom. I will expand because this is in fact your x squared minus 1. It's your difference of squares. So it's equals to negative 2 over 3. And you notice that this and this cancels. Or rather, because these two are the same, we can simply conclude the bottom is the same. So we write x squared minus 1 equals to 3, x squared equals to 4, x equals to plus minus 2. Have a look at the question again. Okay, we have two different values of x, but it seems like there is only one possible coordinate. That is where we need to look for the condition. X is more than 1, which means we reject x equals to negative 2. So x is equals to positive 2. Okay? Hence, we can now go back to the question. We found our x already. Okay? It is at the point P. So, x coordinate of P is 2. Of course, in order for us to link, let's look at the next part first. The equation of the tangent at P, which means to know the equation of the tangent, we must know x and y coordinate of P. We are missing the y coordinate. Okay? So therefore, we need to first find the y coordinate. Y coordinate at P is ln 2 plus 1, or rather, you can just take here directly. Okay? Ln 2 plus 1 over 2 minus 1. This will give me ln 3. Okay? Now I'll zoom out a little bit. I hope you guys can see. Okay, so therefore, P is 2 ln 3. Okay, P is 2 ln 3. Okay, I will write down the rest of the thing first. I think some of you guys are hopping, but let's move on first. It's quite long, this question. Okay, once we know the coordinate of P, we now need to look for the equation of the tangent. But we already know the tangent is negative 2 over 3, right? So therefore, the equation of the curve is y minus ln 3 equals to negative 2 over 3 x minus 2. Simplifying this, I will have y equals to negative 2 over 3x plus 4 over 3 plus ln x. Okay, so now we have pretty much all the information that we need to have. The last thing to do is to find the area of POQ. Okay, first thing first, we already know coordinate of coordinate of P, coordinate of O. We are missing coordinate of Q. So coordinate of Q is given over here. Y-intercept. Okay, sorry. The tangent cuts the P. Sorry, tangent at P cuts the y-axis at Q. Y-axis means we must let this x equal to 0. Okay, so if you let x equal to 0 onto the equation of the tangent, okay, let's write down. equation of tangent. Okay, then y is equals to 4 over 3 plus ln 3. So therefore, coordinate of Q is 0, 4 over 3 plus ln 3. Okay, hang in there. Huh? Now, let us put all the points together. Okay, so this is 0. P ln 3, 2 ln 3 is somewhere around here. And the other one is along the y-axis. So it is actually along here. Okay, so this is Q, this is P, and this is O. So this is the area that we are looking for, which means we need to first find the height. So the height is horizontal. It's literally from 0 to the x value of P, which is 2. So this is 2. Okay, because P is 2 ln 3, right? The gap is between 0 to 2. If you are talking about the vertical height, it's actually from 0 to Q, which is the 4 over 3 ln 3. So this part over here is 4 over 3 plus ln 3. Therefore, the area of the triangle is half times 2 times 4 plus ln. Wrong. 4 over 3 plus ln 3, which will give me 4 over 3 plus ln 3. Okay? This is the answer. Unit squared. Or you can leave it as 3SF. Okay? This is a very tedious 9 mark question, but I hope it makes sense to you. The thinking process and all that. Okay? First step is to differentiate. Then from there you proceed. I kind of need to go. Can you send me the YouTube link? Yes, no problem. I think I got the wrong worksheet. I was busy. I joined late. Okay, let me send you again. Okay, go and download. YouTube will be uploaded in the next day also. Okay, thank you for coming. Okay, I still have one more question. Okay, you need to go. You need to go first. It's okay, no problem. Okay, I was not expecting to cover so many questions. Okay, the last question is very short. It's only 2 marks only. Very, very short. Okay, so if you are willing to sit down, sit through it, I'll be done very soon. Okay, I'll leave this for a minute so that you guys can internalize. Any questions, please let me know. Okay, if not, last question. What's the YouTube channel name? Just look for OVERMUGGED. Yeah, you will see my face or teacher Clarence face for this. Yeah, for this session lah. Because originally it's supposed to be him. I took over him because of some emergencies lah. Okay, last question. Very fast one. Very fast. Very fast. Okay. By the way, yeah, let me just type the channel, YouTube channel, OVERMUGGED. That's all. Okay. Show that this is an increasing function. Straight away differentiate. Nothing else. Okay. But this one, just to warn you guys, this is x ln x squared. Okay. There is a couple of ways you can think about doing this. You can use power rule to bring out the 2 first. Okay. I think it makes life easier also lah. So you just differentiate dy dx is equals to this x and the ln. 2 can put outside first. So when you differentiate x, it's just 1. Copy ln x. Now, product rule is plus. So we put a plus. Differentiate ln x is 1 over x times x. So this will give me 2 ln x plus 1. Okay? So they want you to show that this is an increasing function when x is more than 1 over e. Okay, so let's write down the condition first. We want to prove that this is more than 0. Okay, but we cannot write down straight away more than 0. So what we need to do now is, first thing first, x is more than 1 over e. Our job is to show that this is related to this. But you see, in this question, my function is ln. Right? My function is ln. So there's a problem. So what I need to do is, one very useful trick is that for logarithms and for exponential functions okay, ln x and ex are strictly increasing functions. So what do I mean by that? If they are straightly increasing, if I apply the logarithm on both sides, the inequality is maintained. This is something that is not taught to you in Sec 4 level, okay? Something that is taught in JC level. But we will put it over here because this fact, if you don't use it, you cannot do one. Okay? So what I'm going to do is I'm going to ln both sides. Ln x is more than ln 1 over e. This 1 over e can be written as ln e minus 1 and therefore negative ln e, which is just 1. So this is actually just saying that ln x is more than negative 1. And how this is useful is because if you bring the 1 to the other side, you have ln x plus 1 more than 0, which means this part is positive. Therefore, dy dx is equals to 2 times ln x plus 1 more than 0, which proves that y is increasing for x more than 1 over e. That is all for this question. Looks like it's worth 3 marks actually. But I think they put 2 marks because I think a lot of people cannot do this question. And with that, I am done. Okay? So just take 1 minute to internalize. Any further questions, let me know before I do a bit of closing lah. Okay. For those who need to go off, go ahead and go off first. No problem. Okay. Okay, let me go to my Zoom. Let me stop share. Okay, yes. So just a quick wrap up of everything. Okay. Just to share with you guys. Okay. For overmark, okay, now I'm going to do a bit of selling lah. Okay, for sure. Okay, but this event is to help students to go through the content, and I hope this session really benefited you guys. So if you guys are keen in joining us on a regular basis for even teacher clearance as well, we do provide resources. Okay, so for my math department in particular, we have termly booklets lah. Okay, and once in a while, depending on the tutor, we will have assessments lah. Okay, for Sec course, you are guaranteed to have mock papers one. It's confirm plus have one. Okay, and for my own class, I have cheat sheet. Okay, so these are some of the classes that you guys can look out for. I will particularly go to the math classes. Okay, because this is the main purpose of today, right? It's the math classes. So if you guys are interested, on the right is a QR code. You can go and scan. Okay. So teacher Clarence, he teach Sec 4 A Math on Saturdays and I think one other day. I teach Sec 4 A Math at Coven on Sundays as well as Tampines Friday night. Okay. So you can look for us. And as well as other tutors. Okay. There's teacher Hassan and teacher Jason Yik also. Okay, so if you guys are interested, please come and scan and find out more about us. Okay. If not, recordings will be uploaded on YouTube. Hopefully by tomorrow or latest the day after. The documents I will share with the person to give you guys the Google Drive link and all that lah. Okay, so if not, thank you very much. I will see you guys for tomorrow. If you guys are joining Sec 3 A Math revision. Okay, I'll be conducting tomorrow's Sec 3 A Math revision tomorrow. Yeah. Okay, I'll leave this place open for a while if you guys have any further questions. Okay, if not, thank you very much. Thank you very much. All the best to you guys. See you guys around. Thank you, thank you, thank you. Okay, I'll end the meeting now. Thank you very much. All the best. 加油.